Welcome back to The Explainer. Okay, we've got a lot to cover, so let's dive straight in today because we are unraveling what is honestly a fascinating technological detective story. We're looking at exactly how a blacklisted company managed to just completely bypass restrictions and send shockwaves through the global AI landscape by dropping one of the most powerful models on the market today. Seriously, it's a crazy story of loopholes, open source innovation, and a fundamental shift in how artificial intelligence is being built right now.
So here's the core paradox we're looking at. Picture this. Back in January 2025, the U.S. Commerce Department adds Z.ai, you might remember them as AI, to its entity list. The whole point, citing national security concerns, was to block their access to cutting-edge American tech, right? Makes sense. But fast forward to mid-2026, and this exact same company just released GLM 5.2. This is an open-weight model that is absolutely massive, and it's rivaling, and in some cases straight up beating, the best Western AIs out there. So the obvious question, how on earth did they do it?
Well, the answer actually starts to reveal itself in a really unexpected place. Their December 2025 Hong Kong IPO prospectus. Despite being blacklisted by the US, they successfully went public, raising over $500 million, $558 million to be exact. And right there in that public financial filing, they dropped this total bombshell. They casually state that the entity list designation didn't really hurt them. Why? Because they literally bypass US AI chip export controls by just renting computing resources directly from Chinese cloud providers. They aren't trying to buy the restricted hardware, they're just renting the compute. Analysts look at this and see a massive policy loophole just hiding in plain sight. Section 1, hiding in the open.
But hold on, the hardware loophole? That's really only half the story. The other half is how they got their hands on the actual AI capabilities. To make sense of that, we have to look at this brilliant policy commentary from Kai-Shen Huang over at the DSET Research Institute. Now, back in early 2026, OpenAI and Anthropic were raising massive red flags. They alleged these industrial-scale campaigns by Chinese labs, specifically naming DeepSeek, Moonshot, and Minimax. These labs were supposedly using thousands of fake accounts to secretly extract capabilities and training data from American frontier models. But here's the kicker. Z.ai's name was completely missing from all of these investigations. Nobody caught them extracting data. So where did their frontier-level smarts actually come from?
Section 2, the distillation cascade. Okay, this is where the DSET report cracks open the mystery box that made GLM 5 possible. They call it the distillation cascade, and it perfectly explains how Z.ai could build a top-tier model without ever directly extracting data from American APIs. It basically works in 3 stages. Stage 1, labs like DeepSeek extract capabilities from US models using massive compute power. Stage 2, those same labs then take their architectural innovations and publish them openly, either as open source weights or in technical research papers. Stage 3, labs like Z.ai come in and legally, fully transparently adopt those published innovations. By the time we hit Stage 3, the original US capability has effectively just been transferred through the open source ecosystem. You can actually map Z.ai's history perfectly to the shift. Back in 2022, their GLM 130B model was built entirely on internal innovation from Tsinghua University. Fast forward to 2023, and they started adopting US open source techniques like Google's multi-query attention. But by the time we get to 2026, their GLM 5 model is using core architectural upgrades, things like sparse attention and mixture of experts, which basically optimize how an AI selectively processes information that were overwhelmingly sourced straight from DeepSeek's published reports. That is PRC to PRC transfer in action. Z.ai didn't have to break any API terms of service. They literally just read DeepSeek's technical reports. Section 3, meet GLM 5.2. All right, let's pivot away from policy for a second and talk about the absolute technical marvel that resulted from this loophole. GLM 5.2 boasts an absolutely staggering context window of over 1 million tokens. Just to put that into perspective, that means this model can ingest and understand an entire project's worth of engineering context in a single prompt. It doesn't just read a snippet of code, it retains the module boundaries, the architectural constraints, the API contracts, the whole shebang over long horizon tasks. It's built to take a real complex engineering task from start to finish with unbelievable stability. But as we know, a massive model is totally useless if literally no one can run it. And that is where Unslot's dynamic quantization steps in. Think of it as extreme digital compression. Normally, GLM 5.2 is the 744 billion parameter behemoth that needs 1.51 terabytes of disk space. But Unsloth comes in and compresses it by 84% down to a 2-bit size that only takes up 239 gigabytes. What does that mean for you? It means developers can run this world-class open model locally on a 256GB Mac or even a single 24GB GPU paired with system RAM. It's wild.
Now, you might be wondering, doesn't crushing a model down that small basically ruin its brain? Actually, no. Unsloth's tests show that even at a highly compressed 1-bit size, which reduces its overall footprint by a whopping 86%, GLM 5.2 still retains roughly 76.2% accuracy. That kind of extreme accessibility means developers practically anywhere can experiment with and deploy a frontier-level model on standard consumer-grade hardware. It's a real game changer.
Section 4, Multi-Token Prediction Explained.
So how exactly do they get it so efficient and cost-effective? It comes down to a specific architectural upgrade. Standard autoregressive generation is literally like typing a text message one letter at a time. The AI predicts the next token, adds it to the context, and repeats. It's sequential, and it creates a huge bottleneck. Multi-token prediction, on the other hand, lets the model predict several tokens simultaneously in a single forward pass. It's basically anticipating the sequence way ahead of time instead of just taking the immediate next step. And the benefits here are just massive. By predicting multiple tokens at once, you need significantly fewer forward passes. That directly translates to much faster inference speeds and better long-range coherence in whatever it's outputting. But honestly, the real kicker? Fewer forward passes save an incredible amount of GPU memory bandwidth, which drastically lowers the raw compute cost per output token.
Section 5, Disrupting the AI Market.
Okay, let's zoom out from the microscopic tech specs for a second, because the macroeconomic impact here is huge. When you combine top-tier intelligence with rock-bottom compute costs, you completely disrupt the ecosystem. Look at this data from artificial analysis on the GDV/AAV2 benchmark, which specifically measures real-world agentic knowledge work. GLM 5.2 scored 1524. It isn't just beating other open-weight models like Minimax, it's actually edging out OpenAI's proprietary GPT 5.5. And it's also dominating on design and visual benchmarks, consistently outscoring proprietary models when humans actually judge it for aesthetic and creative tasks. But right here is where the disruption truly happens, the pricing. Z.ai is offering GLM 5.2's API at just $1.40 per million input tokens and $4.40 for output tokens. Now, compare that to a Western proprietary equivalent like Anthropic's Opus 4.6. Artificial analysis ran the numbers, and GLM 5.2 costs just 46 cents per average task. This fundamentally aggressively undercuts the pricing power of Western proprietary models. And developers aren't just flocking to it because it's cheap. It integrates beautifully, it's released under the incredibly permissive MIT license, and it natively supports Model Context Protocol and Agent Client Protocol. If you're building autonomous AI agents or plugging into modern IDEs, those are exactly the tools you need. So it's not just cheap and incredibly smart, it's explicitly optimized for the next generation of autonomous software building.
Section 6, the unstoppable domestic loop.
So to bring this all together, what does Z.ai's success actually mean geopolitically? Well, the new reality is that China's AI ecosystem has officially shifted. They are increasingly independent of direct US API pipelines. That cloud procurement loophole? It's still wide open. They've also managed to make their models hardware agnostic, meaning they run perfectly fine on domestic Chinese chips from companies like Huawei and Cambricon. And most importantly, that PRC to PRC technology transfer we talked about is accelerating at absolute breakneck speed. Which leaves us staring down this final, highly provocative thought from the DSET report. The main pipeline feeding Chinese frontier AI capability has officially moved away from American extraction and into internal domestic circulation. So if the technology is now cascading openly through published research and open source models within China, what happens when preventing extraction from American systems no longer stops the cascade? It's a massive question, and frankly, it's the one that will define the entire next era of global AI competition. Thanks so much for joining me on this explainer, and I'll catch you next time as we keep unpacking the wild world of AI.